Let us study projectile motion on an inclined plane. So here an object is thrown up an inclined plane from the bottom. The angle of projection with respect to the inclined plane happens to be alpha, and the angle of the inclined plane itself happens to be theta. H max is the maximum height attained by the object with respect to the inclined plane. R is the range of the object. So range is nothing but the distance from the point of projection to the point of landing. And u happens to be this vector u. This vector is u, which happens to be the velocity of projection. Let's draw the two axes. So the x-axis has been chosen up the inclined plane, and the y-axis is perpendicular to the x-axis. So u happens to be the velocity of projection. Now we want to analyze this motion in the x direction as well as the y direction. Ux, which is the velocity in the x direction. So ux happens to be equal to u cos alpha. Uy is the velocity in the y direction, and uy happens to be equal to u sin alpha. When we say u, that means the initial velocity. So in order to find the final velocity in the x and y direction respectively, we need to understand that here acceleration due to gravity will be acting not only in the negative y direction but also in the negative x direction. So since acceleration due to gravity g is downward over here, down the plane acceleration due to gravity has a component g sin theta, and perpendicular to the plane acceleration due to gravity has a component g cos theta, and hence here acceleration due to gravity is going to affect the x direction motion as well as the y direction motion, unlike in the case of ground to ground projectile. So the final velocity or velocity at time t, where t is the time before landing, is given as Vx is equal to Ux plus Ax into t. We are simply using the equation V is equal to U plus At. Therefore Vx will be given as U cos alpha, which is the initial velocity in the x direction, minus g sin theta t, because Ax, acceleration in the x direction, happens to be equal to minus g sin theta. Why minus? Because x direction is pointing in this direction and g sin theta is pointing opposite to the x direction. That's the reason for the minus sign. Now Vy will be given as Uy plus Ay t. So Vy can be written as U sin alpha minus g cos theta. So what is the acceleration in the y direction? It happens to be minus g cos theta. Why minus? Again, because the positive y direction is pointing in this way, whereas the acceleration to gravity g cos theta is pointing opposite to the positive y direction. So this is minus g cos theta t. If we want x, then x will be given as, by using the formula, s is equal to ut plus half at square, u cos alpha t minus half g sin theta t square, and y will be given as u sin alpha t minus half g cos theta t square. Now if we would like to find out the maximum height and the time taken to reach maximum height and the time of flight and the range, we use similar logic to the logic or physical intuition that we have used in ground to ground projectile motion. So in order to find the time taken to reach maximum height th, so what do we have to employ? Simply the fact that Vy, the vertical velocity, becomes 0 at th. So putting Vy equal to 0 in order to find th for th, okay, Vy equal to 0, we get 0 is equal to u sine alpha minus g cos theta t. Now this t happens to be th. Therefore, we get th is equal to u sine alpha upon g cos theta. Now, if we want to find, if we were to find tf, if we wanted to find tf, which is the time of flight, then for tf we will use the logic y is equal to 0. So this is the logic being used in order to find th, and in order to find tf we'll use the logic y equal to 0, because if you look at this diagram, then the particle is going to go up, the particle will go up and then come back down on the inclined plane. So y is nothing but the displacement perpendicular to the inclined plane away from the inclined plane. So basically when the particle goes up and comes back down, then y is going to become 0. So using this nugget of physical intuition, we can write y equal to 0 as per the equation y is equal to u sine alpha t minus half g cos theta t square. Putting this to be equal to 0 directly, I get 0 is equal to u sine alpha minus half g cos theta t whole into t. I have taken the liberty to skip a mathematical step, and I have taken t common outside. So this t equal to 0 and this bracket equal to 0 are the two solutions of this equation. T equal to 0 corresponds to the initial point, and this bracket equal to 0 corresponds to the point wherein we get the time of flight. So the time of flight happens to be equal to Tf, which is 2u sine alpha upon g cos theta. This can be noted by the students, and it happens to be equal to twice the time taken to reach the maximum height. So this is something some of you might be slightly surprised, as this motion is not symmetric with respect to the first half and the second half of the motion. In fact, the symmetry is with respect to the ground. Still, the time of flight happens to be symmetric in the sense that th into 2 happens to be tf. Next is to find the maximum height. To find the maximum height, we use the physical intuition that vertical velocity Vy equal to 0 when the particle reaches the maximum height. Using this fact in the equation, Vy square is equal to uy square plus 2 ay into, here we have to write y. So when we put Vy equal to 0, we can substitute y as h max, and ay acceleration happens to be acceleration in the y direction. I'll simply note it down. Acceleration in the y direction happens to be minus of g cos theta, and acceleration in the x direction, ax, happens to be minus of g sin theta. So 0 is equal to uy. What's the value of uy? It's u sin alpha. U sin alpha the whole square plus 2 into minus g cos theta into h max. Therefore, we get h max as equal to u square sine square alpha upon 2g cos theta. So this is the formula that can be noted by the students. Now if we wanted to find the range, we again simply use the logic that range is nothing but x coordinate at time of flight. So we simply take the time of flight and plug it into this x equation. So for range is simply x coordinate at time of flight, TF. So you take this and plug it into the x equation. So that gives you x is equal to u cos alpha, or rather a range equal to u cos alpha into TF. TF is 2u sin alpha upon g cos theta minus half g sin theta 2u sin alpha upon g cos theta the whole square. That's it. Out of these four formulae, I recommend that you learn TH, TF and Hmax. The range formula is slightly complicated. This can be further simplified, but that is not required. You can derive the range formula impromptu as and when required in particular projectile motion problems. Moving on, let us look at projectile motion down an inclined plane. Here alpha is the angle of projection made with respect to the inclined plane. Theta happens to be the angle of the inclined plane with respect to the ground. So this purple line is the path traced by the projectile. Hmax is shown and u is the initial velocity. Let us get the x-axis and the y-axis in the picture. So this is the x-axis and this happens to be the y-axis. So the analysis follows similar logic. Again, we need to understand that down the inclined plane, that means in this direction, acceleration due to gravity happens to be equal to g sin theta. So g sin theta here will be aiding the projectile motion in x direction, and perpendicular to the inclined plane it happens to be equal to g cos theta. Now let me note those two facts down. Ax is equal to g sin theta, positive this time, and ay is equal to minus g cos theta. Negative because it's pointing towards the negative direction of the y-axis. Alright, so what is the initial velocity in the x direction? Ux happens to be equal to u cos alpha, isn't it? And uy happens to be equal to u sin alpha. What is Vx? Vx now happens to be equal to u cos alpha plus ax into t, that is plus g sin theta into t, and Vy happens to be equal to u sin alpha minus g cos theta t. So the velocity in the x direction is continually increasing and the velocity in the y direction is decreasing, because initially decreasing, later when it reaches the maximum height, after that it's increasing because action into gravity happens to be opposite to the initial velocity. The origin of the coordinate system is assumed to be at the intersection point of the x and the y axis shown in the figure. X happens to be equal to u cos alpha t plus half g sin theta t square, and y happens to be equal to u sin alpha t minus half g cos theta t square. Alright, so next we use similar logic and similar physical intuition as in the last case in order to first find time taken to reach maximum height. What was the logic that we used? Simply the fact that Vy equal to 0 at maximum height. So we use the equation Vy equal to 0, which is this equation. We use u sine alpha minus g cos theta t, and we put it equal to 0. So 0 is equal to u sine alpha minus g cos theta t. Now here we can write t as the time taken to reach maximum height. So th happens to be equal to u sine alpha upon g cos theta. Curious that we get the same expression as the case for up and inclined plane. In order to find the time of flight, we again use the same logic, which happens to be y is equal to 0 at time of flight, because the projectile is going to go up and then down again, and the net displacement in the y direction when it reaches the point A, which is the landing point, is going to be equal to 0. So putting y displacement as 0, I am directly going to write down 0 is equal to, again taking the liberty to take t common outside, you get u sine alpha minus half g cos theta t. So this corresponds to the initial point, initial, and the second t corresponds to the time of flight. So the time of flight is going to be equal to tf, that is equal to 2u sine alpha, putting the bracket equal to 0, 2u sine alpha upon g cos theta. Again the same expression that we got for projectile motion up an inclined plane. Alright, so in order to find the maximum height h max, we again use the same logic. Vy is equal to 0 at maximum height. We again use the same equation. Vy square is equal to uy square. Now in this case it's minus 2. I'll directly substitute, or rather, okay, let's write down the equation 2a y. So this is acceleration in the y direction. Now ay happens to be equal to, as is noted down above, minus g cos theta, and when we put this as 0, we get uy square, which is u square sine square alpha plus 2 minus g cos theta, and y now happens to be equal to h max. Alright, so we get u square sine square alpha upon 2g cos theta is equal to h max. This is the maximum height. In order to find the range, we again use the same logic, that range is nothing but x at time of flight. So the range now happens to be equal to r is equal to u cos alpha, and what is the time of flight? Time of flight is 2u sine alpha upon g cos theta. 2u sine alpha upon g cos theta plus half g sine theta. Here there is a plus sign because acceleration to gravity is down the plane, which is aiding the x direction motion for the projectile. G sine theta into 2u sine alpha upon g cos theta, the whole squared. So this happens to be the range. Now one may also remark, as the range was maximum for ground to ground projectile motion when the angle of projection was 45 degree. So what would be the maximum range for a particle on an inclined plane?